Okay, so for chapter 3, we're going to be discussing visual displays of data. I'm recording this differently so you can't see me in the corner, but the quality of the video should be better. I appreciate any feedback. So the first thing we're going to talk about is frequency tables. Here are our learning objectives for today. So a basic frequency table has two columns. The columns are the vertical ones. One column lists all the categories of data, and the other column lists all the frequency of each category, which is the number of data values in this category. So this does work for both qualitative and quantitative data. So let's say I work for the Rocky Mountain Beverage Company and I want feedback on a new product, Coral Cola. I didn't pick the name, and we set up a taste test with 20 people. Then each individual was asked to rate the cola on a 5-point scale. So remember that this would be qualitative ordinal data, just something to keep in mind. Keep checking what type of data it would be. That way we remember it for future projects and exams and things like that. The 20 ratings are as follows: 1, 3, 3, 2, 3, 3, 4, 3, 2, 4, 2, 3, 5, 3, 4, 5, 3, 4, 3, 1. I don't know why I said all that out loud. So let's construct a frequency table for this data. So there were 5 different ratings. 1, 2, 3, 4, 5. A rating of 1 occurred 1, 2 times. So I'm just crossing out the ratings as I count them. 2 occurred 1, 2, 3 times. 3 occurred 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a lot. 4 occurred 3 times, and 5 occurred twice. Sorry, 4 occurred 4 times. That's a 4. This is a 2. And the frequency should add up to 20, right? Because we got 20 ratings. So 2 and 3 and 9, 4 and 2, that does add up to 20. So again, 1 was bad taste, 5 was excellent taste. Do we think this was a good tasting soda based on this rating? I'm guessing not. It's just okay, right? The most values occur right in the middle at 3. I did go ahead and put all the answers into this PowerPoint so you have them to check yourself without the video. Now, aside from the frequency, I can also calculate the relative frequency. The relative frequency of any category is the proportion or percentage of the data values that fall into that category. So in order to calculate the relative frequency, we calculate the frequency of each category divided by the total frequency. We can also calculate the cumulative frequency. That's a little different. I don't really know how beneficial it is, but we're going to do it. So the cumulative frequency of any category is the number of data values in that category and all preceding categories. So let's go ahead and see what this looks like. So like I said, we've been working with the Rocky Mountain Cola Company, and using the taste test data from example 1, here's our original frequency table, we're going to create a relative and cumulative frequency table for this information as well. So in order to take the relative frequency, I'm going to take the frequency at which this category occurred. So right now we're working on a rating scale of 1, and we take it divided by the total number of frequencies in this entire table. So I'm going to take 2 divided by 20, which is 0.10, or I could express that as a percentage, which would be 10%. It's up to you. For the rating of 2, I take 3 out of 20, which gives me 0.15, which would be 15%. For a rating of 3, I take 9 divided by 20, which is 0.45, which is 45%. For a rating of 4, I take 4 occurred 4 times, so 4 out of 20, which is 0.20, which is 20%. and then I take 2 divided by 5, 20. Be careful, that's the rating, that's not the frequency. The frequency is 2. 2 divided by 20 is 0.10, which is 10%. This should all add up to 1 or 100%. Now for cumulative frequency, this is a little bit different. So what we're going to do is we're going to take the number of times a rating scale of 1 occurred. And then for the next row, what we want is the number of times we got a rating of 2 and a rating of 1. So 3 plus 2 is 5. Then for rating of 3, we're going to take 9 plus 3 plus 2, right? We're taking the sum with everything above it, which is 14. Then I've got 4 plus 9 plus 3 plus 2, which is 18. Then I have 2 plus 4 plus 9 plus 3 plus 2, which is 20, right? It should add up to the total number of surveys. So what percentage of the correspondents gave the COLA the highest rating? Well, the highest rating was a 5. Remember, 5 was best taste. So that's going to be 10%. And what percentage gave the COLA one of the 3 lowest ratings? Well, that's going to be, the 3 lowest ratings were 3, 2, and 1. That's 10% plus 15% plus 45%, which is 70%. And I did include the answers. There's 2 little typos right here, but I'm going to fix that before I upload the PowerPoint for everybody. We can also bin data, right? We bin data when it's impossible or impractical to have a category for every value in a data set. This is most common with quantitative data. Say, for example, test scores. I wouldn't want to have a table for every possible test score, like 70, 71, 72, 74, all the way up from 0 to 100. That would make sense, and that's when we need to bin data. It's really important that our data bins are the same size. Meaning, I want to have scores between 70 and 79 because that has 10. I wouldn't want to have a bin if I was scoring an exam. I wouldn't want to have like 70 to 75 and then 76 to 84, right? This has 6 possible values, 70, 71, 72, 73, 74, 75. Meanwhile, this one has 9 possible values. So we got to keep our bins the same size. So let's consider the following set of 20 scores on a 100-point exam. Here are the scores. I'm not going to read them all out loud. We got to determine the appropriate bins and construct a frequency table. That could include columns for relative and cumulative frequency, and we're going to interpret that in this case. So one good way to bin the scores would be by 5s. It's important to note that we aren't going to go like 95 to 100, right? That contains 6 possible values: 95, 96, 97, 98, 99, 100. I know that feels counterintuitive. We're going to go to 99. That way it contains 5 possible values. Then we're going to go from 90 to 94. Then we're going to follow the same pattern for the 80s. Luckily, my lowest test score, that would have been important to look at, my lowest test score is a 72, and my highest test score is a 98, so I don't have to worry about going below 72. I don't need to list categories that are empty. So then I'd have 85 to 89, 80 to 84, 75 to 79, and 70 to 74. Now I can look for the frequency at which these occur. So 95 to 99, that's going to be 1. That's it. I've got 1 exam grade in that range. Then from 90 to 94, I've got 1, 2. That's it, just 2. 85 to 89, I've got 1, 2, 3. 80 to 84, I've got 1, 2, 3, again just 3. Then 75 to 79, I've got 1, 2, 3, 4, 5, 6, 7. And then what remains from 70 to 74, I've got 1, 2, 3, 4. And that is going to add up to 20 because we had 20 total exams. I can then calculate the relative frequency. In order to calculate the relative frequency, I take the frequency that each bin occurred and divide it by our total number in all the bins. So I take 1 over 20, which is 0.05. I could also convert that to a percentage if I wish, but on this example, I'm not gonna. 2 out of 20, which is 0.10. 3 out of 20, which is 0.15. 3 out of 20, which is 0.15. I already knew that. 7 out of 20, which is 0.35. And 4 out of 20, which is 0.20. If you don't want to use a calculator for this, when it comes to working with a divisor of 20, I kind of think of nickels, right? There's 20 nickels in a dollar. So if I have 1 nickel, I have 5 cents. If I have 2 nickels, I have 10 cents. If I have 7 nickels, I have 35 cents. And that is my little trick for working with the denominator of 20. So enjoy. And then all these relative frequencies add up to 1. Again, the cumulative frequency, we're going to take the value of each row and the rows above it. So in this first row, we have 1. This next row, we've got 2. So it'd be 2 plus 1, which is 3. This next row, we have 3. So we have 3 plus 2 plus 1. Remember, I'm taking the sum of everything above it, which is 6. Then I have 3 plus 3 plus 2 plus 1, which is 9. Then I've got 7 plus 3 plus 3 plus 2 plus 1, which is 16. And then I've got 4 plus 7 plus 3 plus 3 plus 2 plus 1, which equals 20. That last entry should always be equivalent to the total number in your bins or the frequency with which they occurred. Again, I did include the answers, so you can always check your work.